Okay, so let's start the topic number systems. So this session will be basically explaining the different types of numbers. For example, what is a number line? What are natural numbers? What are whole numbers? What are integers? What is the difference between rational numbers and irrational numbers? How you will do addition, subtraction, multiplication with rational number and irrational numbers, then how you will draw, how you will mark, for example, root 2. Root 2 is an irrational number. How you will mark an irrational number into a number line, then different identities and laws of exponents. So we will start with the number line. So number line is basically, as the name indicates, this is a line. So this is a line showing the integer values from -3 to 5. Okay, this is an example. Number line is like a line. As the name indicates, this is a straight line. This is a line. There is a 0 point. You can see this is the 0 point. And to the right side, this value is positive, and left side, the value is negative. So to the right side from 0, 1, 2, 3, 4, 5, like that. Continue. Okay, this will continue like this. And similarly, to the left side, the number will continue like this: 0, -1, -2, -3, -4, -5, etc. So the number that will be represented on this line is what is called a number line. Then coming to the second topic, that is the natural number. What are natural numbers? So natural numbers are the set of counting numbers starting from 1. So the first number is 1 and it will continue. So 1, 2, 3, etc. like this. So natural numbers are denoted by the letter capital N. The smallest, please remember, the smallest natural number is 1. Then coming to the next one is whole numbers. What are whole numbers? Whole numbers is represented by the letter W and starting from 0. So natural number starting from 1. So whole number starting from 0. So 0, 1, 2, 3, like that, etc. So as you already know, the smallest natural number is 1, and the smallest whole number is, here the smallest whole number is 0. Okay. Coming to the next one, integers. What are integers? So integers, I will represent this with the letter Z. Integers are a set of whole numbers and their negative counterparts, including 0. That means, for example, I'm writing from -3, -2, -1. These are the negative parts, right? And 0 and +1, +2, +3, like that. So all the negative values, 0 and positive values included in the integers. So integers means integers contains positive numbers, negative numbers, and 0. Coming to the next is rational numbers. What are rational numbers? Any number that can be written in the form of P by Q is what is called a rational number. For example, I'm writing, so 1 by 2. So 1 by 2 is a rational number. So the value of P is 1, the value of Q is equal to 2. Similarly, for example, 3 by 7. 3 by 7 is a rational number. So the value of P is 3 and the value of Q is 7. So any number that can be written in the form of P by Q is what is called a rational number. And what is P and Q? Integers. So this P and Q are integers. That means this can be negative numbers, this can be 0, or this can be positive numbers. And the value of Q not equal to 0. The value of Q not equal to 0. So this will be denoted by the letter capital Q. Okay. Then coming to the next one is equivalent rational numbers. What are equivalent rational numbers? Equivalent rational numbers, first I will write two examples. Sorry, one example. So 2 by 4 and 1 by 2. So this 2 by 4 and 1 by 2 are equivalent rational numbers. So as you already know, what are rational numbers? Any number that can be written in the form of P by Q is called a rational number. So here, this is in the form of P by Q. That means 2 by 4 and 1 by 2 is in the form of P by Q. So these two numbers are rational numbers, right? But when you simplify this 2 by 4, I can write this is 2 by 1. This 4 I can write 2 into 2. So 2 cancelled. So the answer will be 1 by 2. So that means when you simplify this, you will get the same value. That means both are same. So this is what is called a equivalent rational numbers. Equivalent rational numbers. Again, for example, another example, 3 by 6. 3 by 6 are equivalent rational number. Why? Because I'm writing 3 into 1 and this is 3 into 2. So 3, 3. So when I simplify this, I'm getting 1 by 2. So these three numbers, that means 1 by 2, 2 by 4, 3 by 6. All these three numbers are equivalent rational numbers. Why equivalent rational numbers? When you simplify it, you will get same rational number, P by Q. So that is what is called an equivalent rational number. Then next is some statements. Uh, uh, you have to identify whether the statement is true or false. So we will start with every whole number is a natural number. As we know, whole number, right? So whole number is 0, 1, 2, 3, etc. And we know natural number starting from 1, 2, 3, 4, etc. So the statement is every whole number is a natural number. So 1 is a natural number, 2 is a natural number, but 0 is not a natural number. So the statement is every whole number is a natural number. So this is false. Why this is false? Because 0 is not a natural number. So this statement is false. This statement is not true. Then coming to the next statement, every integer is a rational number. First you write integer. We know that what are integers? Integers means negative values. For example, -3, -2, -1, then 0, then 1, 2, 3, etc. So this integers are negative numbers, 0 and positive numbers are called integers, right? So the statement is every integer is a rational number. And what is a rational number? Any number you can write in the form of P by Q is called a rational number. For example, I'm taking -3. I can write -3 as -3 divided by 1. So this is a rational number, right? So P is equal to -3 and Q is equal to 1 and Q not equal to 0. So that means so this -3 is a rational number. That -3 is an integer. This integer is a rational number. Similarly, I can write -2 as -2 by 1. So this -2 is a rational number. -1, I can write -1 divided by 1. Again, this is a rational number. So 0, I can write 0 divided by 1. So the value of P is 0. The value of Q is 1 and where Q not equal to 0. So 0 is a rational number. So again, 1 I can write 1 by 1. So 1 is a rational number. 2 by 1 I can write 2. I can write 2 by 1. So 2 by 1 is a rational number. So 3 I can write 3 by 1. So that means every integer is a rational number. So this statement is true. This statement is true. Then every rational number is an integer. Okay, so a rational number, as we already know what is a rational number. Any number in the form of P by Q is called a rational number. But the integer is negative values, 0 and positive values are called integer. So every rational number is an integer. A rational number is any number that can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. However, not all rational numbers are integers. For example, 1 by 2. 1 by 2 is a rational number, right? 1 by 2 is a rational number, but this is not an integer. So hence this statement is false. Okay, so this statement is false. Then coming to the next one. So find five rational numbers between 1 and 2. Okay, so we have two numbers, 1 and 2. So we should write 5. 1, 2, 3, 4, 5. So we should write 5 rational numbers between 1 and 2. Rational numbers means a number that can be written in the form of p by q. So what I am doing is I am writing this one as 10 by 10, right? Like a rational number. What is 10 by 10? 0, 0 cancel, 1 by 10. So this one I can write 10 by 10. Similarly, this 2 I can write 20 by 10. Okay, so that means 0, 0 cancel. This is 2. So check the denominator. Denominator is same. Okay, denominator same. So here this 2 I can write 20 divided by 10. So next rational number you can easily write after 10. What is the next number? 11. 11 by denominator is same 10. After 11, next number is 12. 12 by 10. So 13 by 10. 14 by 10. 1, 2, 3, 4. The next number is 15 by 10. That means, so 10 by 10 is 1, right? 1. What is 11 by 10? 1.1. That means after 1, next number is 1.1, 1.2, 1.3, 1.4, 1.5, then 2. So these are the 5 rational numbers. Rational numbers, this one, p by q form. Rational numbers between 1 and 2. So in this way you can find any type of rational numbers between any two numbers. Then next one. Next, again, there is a statement, is 0 a rational number? Okay, so we know that what is a rational number? Any number that can be written in the form of p by q is called a rational number. So 0 is an integer. I can write 0 as 0 divided by 1. So the value of p is 0, the value of q is equal to 1, and q not equal to 0. So 0 is a rational number. Yes, 0 is a rational number. Then find 6 rational numbers between 3 and 4. So we already studied rational numbers between 1 and 2. Next, I am writing 6 rational numbers between 3 and 4. Okay, the same principle I can use. This 3 I can write 30 divided by 10. Okay, 30 divided by 10. This 4 I can write 40 divided by 10. So check the denominator. Denominator is same. Okay, denominator same. Denominator same. So after 30, you can write next number 31 by 10, then 32 by 10, 33 by 10, 34 by 10, 35 by 10, 36 by 10. These are the 6, 1, 2, 3, 4, 5, 6. These are the 6 rational numbers between 3 and 4. That means this is in the form of what? P by Q. So it's very, very easy. Then next is find 5 rational numbers between 3 by 5 and 4 by 5. So I have two numbers, 3 by 5 and 4 by 5. Okay, so how you will write? First, I am writing this 3 by 5 as 30 by 50. So 0, 0 cancel. This is 3 by 5, right? This 4 I can write 40 by 50. So 0, 0 cancel, 4 by 5. So check the denominator. Denominator same. So make sure that your denominator is same. Denominator same. So after 30, you can write what is the next, sorry, after 30, what is the next number? 31 by 50, next is 32 by 50, 33 by 50, 34 by 50, 35 by 50, like that. So you can write like this. This is the, how many rational numbers required? 5 rational numbers, right? 1, 2, 3, 4, 5. So these are the 5 rational numbers between 3 by 5 and 4 by 5. Okay, then again there is a statement. State whether the following statements are true or false. Every natural number, again, you know what is a natural number? A natural number starting from 1, 2, 3, etc. Every natural number is a whole number. So whole numbers starting from 0, 1, 2, 3, etc. Every natural number, so natural number starting from 1. So 1 is a whole number. Then next number is 2. 2 is a whole number. 3, again 3 is a whole number. That means every natural number is a whole number. So the statement is true. Because natural number starting from 1. So whole number starting from 0, 1. So so all the natural number, every natural number is a whole number. For example, 1, 2, 3, etc. Natural sorry, a whole number. Every natural number is a whole number. Very, very easy. Then next is next statement, every integer is a whole number. As we know, what is an integer, right? Negative values, 0, and positive values are in integers. But we know that whole numbers starting from 0, 1, 2, 3, right? There is no negative values in the whole numbers. So the statement is every integer is a whole number. No, it's false because negative numbers are not included in the whole numbers. So the statement is false. Every integer is a whole number. This statement is false. Next. Every rational number is a whole number. Okay, we know that what is a rational number. Any number that can be written in the form of P by Q is called a rational number, right? Rational. And we know that what are whole numbers? Whole numbers are 0, 1, 2, 3, etc. So any number that can be in the form of P by Q is called a rational number, but whole numbers are starting from 0, 1, 2, 3, etc. So the statement is every rational number is a whole number. That means this is false. Okay, then coming to the next topic, irrational numbers. Irrational numbers means rational numbers we know. Any numbers that can be written in the form of P by Q, where P and Q are integers and Q not equal to 0 is called a rational numbers. Irrational numbers means numbers that cannot be expressed in the form of as the ratio of two integers. That means P by Q form. We cannot express the ratio of two integers. This is what is called irrational numbers. We cannot express. If we can express as the ratio of two integers, then it is called rational numbers. If we cannot be expressed as the ratio of two integers, then the numbers are called irrational numbers. So they have a non-terminating and a non-repeating decimal expansion. So the common examples are pi. Pi is an irrational number. You know what is the value of pi? 3.141592, like that. Then you know root 2. Root 2 is an example of irrational number. Then Euler's number is an example of irrational number. Any number that cannot be expressed as the ratio of two integers is what is called irrational numbers. Then next is what are real numbers? Real numbers we will represent using the letter capital R. Real numbers means it consists of both rational numbers and irrational numbers. It is the combination of that means the numbers consist of both rational numbers and irrational numbers are called real numbers. Then coming to the next one. Yeah, as I already mentioned, root 2. Root 2 is an irrational number, right? Root 2 is an irrational number. Root 2 is an irrational number. How you will locate this irrational number on a number line? As we know, number line will be like this: 0, 1, sorry, 0, 1, 2, 3, like that, right? But how you will represent as we discussed, real numbers means it is the numbers that consist of both rational numbers and irrational numbers are called real numbers. So how you will represent this irrational number on a number line? Okay, it's very difficult, but we will use Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. So if we have a right angle triangle like this angle is right angle, that means 90 degree. The side opposite to this right angle is called hypotenuse, and this is called a base, and this is called altitude. So there is a relation, Pythagoras theorem, hypotenuse square equals base square plus altitude square. This is the relation. Hypotenuse square equals base square plus altitude square. So we will apply the same idea here on this number line. So we will start from 0. Okay, there is a 0 point. Then first we will locate a point. So the distance is 1 unit. Okay, so that means this base is 1 unit. And then draw a vertical. And this altitude is 1 unit, same. Okay, so then draw a right angle triangle like this. Okay, so then you can calculate hypotenuse because you know the base, right? What is the value of base? Base is 1, altitude is 1. So hypotenuse square equals, base square plus altitude square, right? Or hypotenuse equals square root of base square plus altitude square. So what is base here? 1, right? So that means here you can see that means square root of 1 square plus 1 square. That means what is square root of 1 square is 1. Square root of 1 square is 1. So that means 1 plus 1, square root of 2. So hypotenuse, so the value of hypotenuse is root 2. So this side is root 2. Understand? This side is root 2. Then the next step is very simple. Now this is root 2. This hypotenuse is root 2. Take your compass. Okay, and this O is the center. O is the center, and radius hypotenuse. Take the radius hypotenuse. That means this root 2. Then draw an arc from here to the number line. Okay, so this will be root 2. Okay, this will be root 2. So in this way, you can mark the irrational number of root 2 on this number line by using what? By using Pythagoras theorem. One more example, how you will locate root 3 on the number line. Same principle. First, we will start with the base 1. So this is 1. Then draw the altitude 1. Then find root 2. So this is root 2. Okay. Then from that, I will draw another triangle. So this altitude is 1. And so I will mark here so that you can easily understand. So starting from the base, so this is 1, this is 1, this is root 2. Understand? Okay, then I will from here I will draw another line. This is 1 unit. Okay, and then so this is a right angle triangle. This angle is 90 degree. So this means hypotenuse of the second triangle. This is the hypotenuse. This is the hypotenuse of second triangle, right? Same. You have to apply the Pythagoras theorem, square root of base. What is the base here? Base is root 2. Okay. So here you can see base is root 2. Okay. So root 2 square plus what is the here? This is the altitude. Okay. This is the triangle 1. So that means 1 square. So that means you can get what is a root 2 square? Root 2 square is 2. 2 plus 1 square is 1. So 2 plus 1 is 3. That means square root of 3. So you will get hypotenuse equals. So you will get hypotenuse equal to root 3. By applying the Pythagoras theorem, you will be getting hypotenuse as root 3. Then same principle, take your compass. So here this is the center. And so the circle is here is wrong actually. So you have to take this distance till this distance, okay, because this is root 2, like this. Okay, so this is the root 3, understand? This distance is root 3. This is the hypotenuse, root 3. So this is the center, this O is the center, O is the center, and this is the radius. Draw an arc. You will get what? You will get root 3. You will get root 3 on the number line. So in this way, by applying Pythagoras theorem, in this way you can locate irrational numbers on the number line. Okay. Then next is the real numbers and their decimal expressions. So as I already mentioned, real numbers are what? Real numbers are rational and irrational. Rational and irrational. So that means rational means any number in the form of p by q, right? Any number in the form of p by q. For example, 1 by 2. So what is, when you divide 1 by 2, what is the answer? 0.5 is the answer. So this is what is called a terminating decimal. Terminating decimal. Terminating decimal. That means after 5, there is nothing repeating, right? So 0.5 is the final answer. There is nothing repeating. So this is what is called a terminating decimal. Another example, I'm writing 1 by 3. What is 1 by 3? When you divide 1 divided by 3, you will get 0.3333 like that, etc. Now, this is what is called a non-terminating. Okay, this is what is called a non-terminating. This is what is called a non-terminating, but this is what repeating, because here this 3 is repeating, right? So this I can write 0.3, a bar on the top of this 3. I will mark a bar on the top of 3. What is the meaning of this is, that means this 3 is repeating. This is the meaning. Okay, so this is what is called a non-terminating. 1 by 3 is a rational, 1 by 3 is a rational number, but 1 by 3 is a real number. And this, the decimal expansion is non-terminating, repeating. Understand? Non-terminating, repeating. Then coming to the next one, pi. So what is the value of pi? So the value of pi is 3.141592653, etc. Right? So this is an irrational number. This is an irrational number, and this is non-terminating. This is non-terminating, non-repeating, because nothing, no pattern. You can't see any pattern. This is non-terminating, non-repeating. Similarly, the value of root 2 is an irrational number, and the value is 1.414213562, etc. Again, this is an irrational number. This is non-terminating. This is non-terminating. This is non-terminating and non-repeating. This is non-terminating and non-repeating. This is non-terminating and non-repeating. Understand? Okay. Again, 1 by 2, I already explained. 1 by 2 means 0.5. What is this? This is terminating. This is terminating. And 3 by 4. What is 3 by 4? 0.75. What is this? This is terminating. This is terminating. Okay. Then another example. So another example is 3 by 8. Okay. So 3 by 8 is 0.375. So this is terminating. This is terminating. 3 by 8 is 0.375. This is terminating. So non-terminating, I already told you 1 by 3. What is the solution of 1 by 3? 0.333, etc. That means 3 is repeating. we will be writing 0.3. There is a bar on the top of this. That means 3 is repeating. So this is repeating because here 3 is repeating. Then another one is 2 by 9. So 2 by 9 is 0.2 bar. That means 2 is repeating. Okay. 10. Next example, 10 by 3. Okay, what is 10 by 3? Okay, so the answer of 10 by 3 is 3.333, etc. That means here 3 is repeating. That means you can write 3.3 bar. 3.3 bar. That means this is non-terminating but repeating. Here repeating means here this 3 is repeating, but this is non-terminating. So this is non-terminating repeating. Then 7 by 8. The value of 7 by 8 is 0.875. So this is terminating. This decimal expansion is terminating. Then 1 by 7. Okay, 1 by 7 is 0.142857. Okay. Then again, this will be repeating. That means 142857. Again, 142857, etc. So this will be repeating like this. So I can write this will be equal to 0.142857 bar like this. That means this is non-terminating repeating. So the repeating numbers are from 1 to 7, right? 142857 is so this is what? This is non-terminating. This is non-terminating. This is non-terminating but repeating. Okay, here this numbers are repeating. 142857. These numbers are repeating. These numbers are repeating. Okay. Then next, show that 3.142678 is a rational number. 3.142678. You should write this number as a rational number. What is a rational number? Any number in the form of P by Q is called a rational number. How you will write? So just first you can shift this decimal to the right end. Okay. So that means 3.142678. So divided by, so you shifted the decimal from how many places? 1, 2, 3, 4, 5, 6. That means you divided with the 1. How many zeros? 1, 2, 3, 4, 5, 6. So this is which form? P by Q form. So this number I'm writing like this, rational number. So 3.142678. I'm converting that number into rational form as 3142678 divided by 1, 0, 0. How many zeros? 6 zeros. Okay. Next question. Yeah. Next is we have a number. Okay. So the number is 0.3333, etc. So the question is, we have to convert this as a rational number. Rational number means what? P by Q form. You should write this number as a P by Q form. Here, this is what is non-terminating repeating, right? So first I am putting this number as X. Then I am checking how many numbers are repeating. Here I can see one number is repeating, right? One number repeating. One number is repeating. That means only 3 is repeating. So I am multiplying this equation with the 10. So 10 into X, that will be equal to 10 into 0.3333, etc. So what is 10 into X? 10X. So 10X will be, what is 10 into 0.333? Shift this decimal to one place, right? Because I am multiplying this 10. That means 1, 0. That means shift this decimal to the next place. That means 3.333, etc. So now we have two equations. I'm subtracting this. This is equation number 2, and the first one is equation number 1. So I'm subtracting 2 minus 1. So what is equation number 2? 10x. So 10x minus, what is first equation? X. That will be equal to 3.333, etc., minus 0.333, etc. So subtract it. 3 minus 3 is 0, 3 minus 3 is 0, 3 minus 3 is 0, point 3 minus 0 is 3. What is 10x minus x? 9x. So 9x equal to 3. So x will be equal to 3 by 9. So that means 1 by 3. So this number, which form? P by Q form, right? So we equate the given number as x. Now I got the value of x in the form of a rational number, P by Q form, 1 by 3. Okay, so in this way, you can write the given decimal expansion numbers into rational number like this, P by Q form. First you equate this number with the x, then you check how many numbers are repeating. If one number is repeating, multiply with the 10. If two numbers are repeating, multiply with 100. If three numbers are repeating, multiply with 1,000, like that. That is the simple process. Okay, I'm explaining one more problem. Okay, here you check. Here the given number is here. Here again the question is one. Here we have the number 1.272727, etc. That means this 27 is repeating. That means two numbers are. That means here two numbers are repeating. So first I am writing x equal to this one. This is equation number 1. Then I am multiplying this with a not 10. The previous problem I multiplied with the 10 because only one number is repeating. In this case, two numbers are repeating. So I am multiplying with 100. So 100 into x is equal to 100 into 1.272727, etc. Okay. So what is 100 into x? 100 into x is 100x equals. So I am multiplying with the two zeros. So shift this decimal to two places. Okay. That means 27, right? Okay, see here. Okay, so the decimal will be here. That means 127. Okay, so I am shifting this decimal to two places. Why? Because I am multiplying with 100. That means two zeros. So two places. So 27.2727, etc. So this is equation number 2. Then same process, 2 minus 1. 2 minus 1. So 100x minus x equals 127.2727, etc. minus 1.2727, etc. So subtract it. 7 minus 7, 0. 2 minus 2, 0. 7 minus 7, 0. 2 minus 2, 0. 0.7 minus 1 is 6. 2, 1. So what is 100x minus x? 100x minus x is 99x. So 99x will be equal to 126. So what will be x? X is equal to 126 divided by 99. So now this is in the form of what? This is in the form of P by Q. So the given number is x. What is the value of x? 1.272727, etc. So I wrote that the given number in the form of a rational number. That means P by Q form. So the answer is 126 divided by 29. 126 divided by 29. Okay, then coming to another example. Yeah, another same example. Show that the given number is, so the given number is 0.235, then 35. So that means the 35, etc. That means here 35 is repeating. Okay, so here 35 is repeating. So same process, I am writing x equal to this one. Then next time I am writing this as equation number 1. Then I am multiplying with 100. Why I am multiplying with 100? Because two numbers are repeating. 3 and 5 are repeating. So 100 into x is equal to 100 into 0.235, 35, etc. So 100 into x is 100x equals. So I am multiplying with 100. That means shifting this decimal to two places. That means 23.5353, etc. Okay. So this is equation number 2. So then equation number 2 minus equation number 1. What is equation number 2? 100x minus x will be equal to 23.5353 etc. minus 0.235235 etc. So 3 minus 3 0, 5 minus 5 0, 3 minus 3 0, 5 minus 2 is 3, then 23. That means 23.3. Okay, 23.3. So what is 100x minus x? 99x. So 99x will be equal to 23.3. So here there is one decimal, right? So I am multiplying with the 10. Multiplying with the 10. That means I will be getting 99x into 10 equals 23.3 into 10. So 99x into 10 means 990x equals to, here I am multiplying with the 23.3 into 10. Okay, shifting this decimal to the right side. That means 233. So the value of x will be 233 divided by 990. So the value of x equal to 233 by 990. So this is in the form of what? P by Q, right? Rational number. So the given number is 0.2353535. So we wrote the given number as a rational number, 233 divided by 990. So the step is very simple. Then next question. Find an irrational number between 1 by 7. So 1 by 7 and 2 by 7. Okay, so we know that what is 1 by 7? 1 by 7 is equal to 0.142857, etc. So this is an irrational number. Okay, so 2 by 7, what is 2 by 7? 2 by 7 is equal to 0.285714, etc. So these are I can take 1 by 7 as, so just I'm taking this as 0.142857, and this 2 by 7 as 0.285714. Okay, so this is non-repeating and a non-terminating. So this is a rational, this is an so this is 0.1428 and this is 0.28, right? So I can write an irrational number, for example, 0.200, then 2000, 2, then 1, 2, 3, 4, etc. like this. So this is 0.14, then this is 0.28, right? So after 0.14, this number is 0.20, right? So this number is in between 0.142857 and 0.285714. Then coming to the next one. Next, 36 by 100. What is 36 by 100? 36 by 100 means 0.36. This is what? This is a terminating decimal, because after 6, nothing, no number. This is terminating decimal. So 1 by 11. What is 1 by 11 is 0.09090909 like this. That means this will be 0.09 bar. That means this is non-terminating repeating. This is non-terminating repeating. This is non-terminating repeating. This 09, this is repeating. 09 is repeating. This 09 is repeating. Then next is 4 and 1 by 8. Okay, so 4 and 1 by 8 will be equal to 33 by 8. So when you divide this, you will get 4.125. Okay, that's it. Okay, 4.125. That means terminating. So after 5, there is no number. So this is terminating. Then another number is 3 by 13. 3 by 13. 3 by 13 will be, when you divide this, you will get 0.230769. Again, this is repeating 230769, 230769, etc. like this. So I can write 0.230769 bar. So this is repeating. That means this is what? This is non-terminating because this is going like this, non-terminating but repeating. So this part is repeating. This part is repeating. Next is 2 by 11. So 2 by 11 is 0.181818, etc. So that means 0.18 bar. Okay. Again, this is non-terminating but repeating. So here the repeating decimal is this one. 18. 18 is the repeating decimal. And the next question, 329 divided by 400. So this will be 0.8225. So this is called a terminating decimal. So after 5, there is no numbers. That means 0.8225. So this is terminating decimal. Okay, next question is 1 by 7. 1 by 7 is given. 1 by 7 is 0.142857 bar. That means repeating. Calculate what is the value of 2 by 7 using this. So how you will calculate 2 by 7? Just to multiply this. Just to multiply this with the 2, you will get 0.285714. Understand? Next is 3 by 7. Okay, you just multiply this with 3. Just to multiply this with 3, you will get the answer is 0.428571 bar. Okay. Similarly, you can calculate 4 by 7, multiply with, so multiply this with the 2, multiply with the 3, multiply with the 4, multiply with the 5. Okay. Then 5 by 7, multiply with the 6, you will get 6 by 7, etc. Very simple. Next question. Okay, so this one I already explained. So the given number is 0.6666, etc. So here 6 is repeating. So you have to multiply with the 10 because one number is repeating. Then put the given number is x, equation number 1. Then multiply with the 10. Then this is equation number 2. Then find 2 minus 1. Okay, so find 2 minus 1, you will get the solution. So here the solution is 2 by 3. Very simple. It's very simple, direct. Okay. So check the previous problem and try the same principle apply here. You will get the answer. And the next one is 0 point. So here the number is 0, x equal to 0.47777, etc. That means 7 is repeating, right? 7. That means one number is repeating. So first I am giving this is equation number 1. Then this is equation number 2. Multiply with what? Multiply with the 10 because one number is repeating. Then find 2 minus 1. Equation number 2 minus equation number 1. You will get the answer. So the answer is 43 by 90. So you can write the given number in the form of rational number 43 by 90. Very simple. Then the next problem is 0.001. 001. 001. Here the thing is that this 3 numbers repeating. 3 numbers repeating. That means you have to multiply with 1,000 because there are 3 numbers repeating. So first I am giving x equal to this one, equation number 1. Then multiply with 1,000. Okay, remember this point. Multiply with 1,000. Why 1,000? Because here how many zeros? 3 zeros. Why 3 zeros? Why 3 zeros? Because there are 3 numbers. There are 3 numbers repeating here. If there are 2 numbers repeating, you have to multiply with 100. If there is only one number repeating, like the previous problem, you have to multiply with 10. But here there are 3 numbers repeating, so you have to multiply with 1,000. Then you have to find 2 minus 1. Equation 2 minus equation 1. You will get the answer 1 by 999. This is in the form of p by q, rational number. Very simple. Okay. Same thing here. Same problem. Here again, x equal to, the given problem is 0.999, etc. So here one number is repeating. One number repeating. So that means this is equation number 1. Then you have to multiply with 10. Okay, why you multiply with 10? Because one number is repeating. This is equation number 2. Then equation number 2 minus 1. When you subtract equation 2 minus 1, you will get the answer x equal to 1. So the answer is 1. So that means 0.99. So 0.9999, etc. That will be equal to what? That will be equal to 1. Okay. So this is a very good, very important point. Okay. Then 1 by 2, I already explained what is this 0.5. What is this? This is terminating decimal, right? Then 1 by 5, that is 0.2, again terminating decimal. What is 3 by 8? 3 by 8 is 0.375, again terminating decimal. 7 by 25, 7 by 25 equals 0.28, again what is again terminating decimal. So irrational numbers we already discussed. Irrational numbers we already discussed. Root 2. Root 2 is an irrational number. Pi is an irrational number. E is an irrational number. What is the value of root 2? 1.414, like that, etc. So this is the number. I'm not writing the full number. 1.414213562373091, etc. So non-repeating, non-recurring. So the value of pi is equal to 3.1415, etc. So the full the number you can see 3.141592653589793, etc. Then next is Euler's number E. So the value of E is equal to 2.71828, etc. So E is equal to 2.718281, etc. So these are non-terminating. These are what? These are non-terminating, non-recurring, or non-repeating numbers, or irrational numbers. Okay. So classify the given numbers as rational or irrational. So root 23. So root 23 is not a perfect square, right? So root 23 is irrational. Irrational. Then root 225. What is root 25? Root square root of root 225 is 15. So 15 I can write 15 by 1 in the form of p by q. That means this is a rational number. So root 25 is what? Root 25 is a rational number. Square root of 225, not 25. Square root of 225 is a rational number. Then 0.3796. I can write this number 3796 divided by how many decimal? 1, 2, 3, 4. That means divided by 1, 2, 3, 4 zeros. So this is in the form of p by q. That means this is a rational number, not irrational. So this number 0.376 is a rational number. Is a rational number because I can write this in the form of 3796 divided by 10,000. Okay, like that. Then next is 7 root 5. What is this? Is it a rational number or irrational? 7 is an what is 7 is a rational number, but root 5 is an irrational number. So when you multiply a rational number with the irrational number, the solution will be irrational. Irrational number. So this is 7 root 5 is an irrational number. 7 root 5 is an irrational number. 7 root 5 is an irrational number. Then next is 7 by root 5. So 7 by root 5. Again, 7 is what? 7 is a rational number because 7 I can write p by q, 7 by 1, one form. Root 5 is an irrational number. So when you divide a rational number with a rational number, this is irrational. So this is again what? This is again irrational. Then next is root 2 plus 21. So root 2 is what? Root 2 is an irrational number and 21 is a rational number. When you add an irrational number with a rational number, this is irrational. So these are different operations, okay? Addition, subtraction, multiplication, division, etc. Next is pi minus 2. So pi minus 2. Pi is what? Pi is irrational number. Pi is a rational number. 2 is what? 2 is rational number. When you subtract it, you will get irrational number. You will get irrational number. Okay? Irrational number. Then next is addition. Addition of this expression. What is this expression? 2 root 2. 2 root 2 plus 5 root 3. Addition means plus. Root 2 minus 3 root 3. Okay. So here you can see this is 2 root 2 and this is root 2 means 1 root 2, right? So these two terms are like 2 root 2 and 1 root 2. You can add directly 2 plus 1, 3. That means 3 root 2. And the next is next two like terms are 5 root 3. This is 5 root 3 and this is minus 3 root 3. Again, these two terms are like. So you can take 5 minus 3. What is 5 minus 3? 2. That means plus 2 root 3. So the answer is 3 root 2 plus 2 root 3. So this is the answer. 3 root 2 plus 2 root 3 is the answer. Then next is we can do some operations, addition, subtraction, multiplication, etc. Okay. So, okay. So 6 root 5, sorry, I'm taking another color. It's not, yeah. So 6 root 5, 6 root 5. So this is multiplication, multiply. So that means 6 root 5 into 2 root 5. What is 6 into 2? 6 into 2 is 12. Then into root 5 into root 5. What is root 5 into root 5? Root 5 into root 5 is 5. So what is 12 into 5? 12 into 5 is 60. So the answer is 60. Very simple. Then another is a division. Divide. So this is division. Okay. So 8 root 15 divided by 2 root 3. So this will be 8 into root 15. I can write 5 into 3. Root 5 into root 5 into 3 divided by 2 into root 3. This is again I can write 8 into root 5 into 3. I can write root 5 into root 3. I can split this as root 5 into root 3 divided by 2 into root 3. So this root 3 cancel. This 2, this 8 cancel 4. So the answer is 4 root 5. So what is the answer? Answer is 4 root 5 answer. Answer is 4 root 5. So the next question is simplify 5 plus root 7 into 2 plus root 5. So 5 plus root 7, 5 plus root 7 into, so this is multiplication, into 2 plus root 5. So first multiply with the 5 into 2. That means 5 into 2 plus, then 5 into root 5. So that means 5 into root 5, then plus. Next is root 7 into 2. That means 2 root 7 plus. Next is root 7 into root 5. Root 7 into root 5. What is 5 into 2? 5 into 2 is 10. 10 plus 5 into root 5. So 5 root 5 plus. Next is 2 into root 7. 2 root 7 plus root 7 into 5. What is root 7 into 5? 7 into 5, 35. That means root 35. So this is the final answer. 10 plus 5 root 5 plus 2 root 7 plus root of 35. This is the final answer. Next is 5 plus root 5. 5 plus root 5 into 5 minus root 5. Okay. So this is in the form of a plus b into a minus b. This is an identity, a plus b into a minus b. What is the identity? A plus b into a minus b is a square minus b square. So the answer I can write a square is 5 square, a square minus b square is root 5 the whole square. So 5 square is 25 minus root 5 square is root 5 into root 5, that is 5. So 25 minus 5, so the answer is 20. So the answer is 20. Then next question, root 3 plus root 7 the whole square. This is in the form of a plus b the whole square. What is a plus b the whole square? A plus b the whole square is a square plus 2ab plus b square. So I am using the same identity here. That means a square. A square is root 3. So root 3 the whole square. A square plus 2 into a is root 3. 2 into a into b. B is root 7. 2ab plus b square. B square is root 7. B square is root 7 the whole square. So root 3 square means 3 plus 2 into, what is 7 into 3? 21. So root of 21 plus, what is root 7 square? Root 7 square is 7. So 7 plus 3 is 10. So 10 plus 2 root 21. So the answer is 10 plus 2 root 21. So the final answer is 10 plus 2 root 21. Next question is root 11 minus root 7 square root of 11 minus square root of 7 into square root of 11 plus square root of 7. This is again in the form of a minus b into a plus b identity. What is a minus b into a plus b? This is equal to a square minus b square. So root of 11 a square minus b square, root of 7 square. So root of 11 square is 11. Root of 11 square means root 11 into root 11. That is 11. 11 minus root 7 square is root 7 square is root 7 into root 7. Root 7 into root 7 is 7. So 11 minus 7. So 11 minus 7 is equal to 4. So the final answer is 4. In this way, you can add, you can subtract, you can multiply, you can divide the rational and irrational numbers. Next is rationalize the denominator. Okay, the given number is 1 by root 2. So rationalization means here check, here the denominator is what? Here the denominator is an irrational number. You have to convert this number into a rational number. Rational number means what? Any number you can write in the form of p by q is what is called a rational number. So you have to convert this number into the denominator. You have to convert the denominator of the given number into rational number. This is what is called rationalize. So what I'm doing is 1 by root 2 into, I am just multiplying this with the root 2 by root 2. So root 2 by root 2. So that means root 2 cancel, both are same, right? So the numerator will be root 2 into 1 is root 2 divided by, denominator is root 2 into root 2. What is root 2 into root 2? 2. Okay, now this is what? Now this is a rational number. Okay, so 1 by root 2 will be equal to what? 1 by root 2 will be is equal to root 2 by 2. So I'm converting this, the given number 1 by root 2, where the denominator is an irrational number. I converted into what? I converted into a rational number. This is what is called a rationalize or rationalization. Then next number is 1 divided by 2 plus root 3. Here the denominator is again again an irrational number, right? Because here the denominator is adding 2 is a rational number, but a root 3 is an irrational number. As we already discussed, when you add a rational number with an irrational number, you will be getting an irrational number. So this is the denominator will be an irrational number. So how you will convert this, the denominator, into rational number? So here what I'm doing is I will multiply the conjugate of this. That means 1 by 2 plus root 3 into 2, I am multiplying with the 2 minus root 3 divided by 2 minus root 3. That means multiplying the conjugate. Multiplying with the this is 2 plus root 3, take the minus, that means the conjugate. So 2 minus root 3 divided by 2 minus root 3. 2 minus root 3, 2 minus root 3 cancel, both are same. So what will be the numerator? Numerator will be 1 into 2 minus root 3 is 2 minus root 3 divided by, so denominator is in the form of what? A plus b into a minus b form. What is a plus b into a minus b? A square. That means 2 square, a square minus b square. B square is root 3 square. So this will be equal to 2 minus root 3. 2 minus root 3 divided by, what is 2 square? 2 square is 4 minus root 3 square. What is root 3 square? Root 3 square is root 3 into root 3. Root 3 into root 3 is 3. So this will be equal to 2 minus root 3. 2 minus root 3 divided by 4 minus 3 is 1. Okay. Now this will be equal to what? This will be equal to 2 minus root 3 divided by 1. So the given irrational number, the denominator of this irrational number is converted. This converted to what? Rational number. This is what is called a rationalize or rationalization. Then take the next one. 5 divided by, same process, 5 divided by root 3. 5 divided by root 3 minus root 5. So multiply the conjugate here into, here this is minus. So I am multiplying with the root 3 plus root 5 divided by root 3 plus root 5. Okay. So the numerator will be 5 into root 3. What is 5 into root 3? 5 into, so I am writing numerator is 5 into root 3 plus root 5. Correct? The whole divided by, this is a plus b into a minus b. A plus b into a minus b is a square. A square is root 3 square. A square minus b square. B square is root 5 the whole square. So this will be equal to 5 into root 3 plus root 5. What is the denominator? Root 3 square is root 3 into root 3 is 3 minus root 5 into root 5 is 5. So 3 minus 5. So this will be equal to 3 minus 5 is minus 2. Right? So that means minus 5 by 2 into root 3 plus root 5. This is the answer. Understand? Very simple. Multiply the conjugate. That's it. So now check the denominator. Denominator is in rational number, right? Yes. Then coming to the next one, that is 1 by 7 plus 3 root 2. Multiply with the, here the sign is plus, multiply with the 7 minus 3 root 2 divided by 7 minus 3 root 2. So the numerator will be 7 minus 3 root 2 divided by, this is in the form of what? A plus b into a minus b. That means a square minus b square. So this will be 7 square. 7 square is what? 49. So a square minus b square. B square is 3 root 2 square. That means 3 square root 2 square. So what is root 2 square? Root 2 square is root 2 into root 2. 2. So that means 3 square is 9. 9 into 2, 18. That means 49 minus 18. So this will be 7 minus 3 root 2 divided by, what is 49 minus 18? 31. So this is the answer. Now check the denominator. Denominator is a rational number, right? But the given is what? Given is irrational number. Okay, so convert this given the denominator of this to rational. This is what is called a rationalization, or rationalize the denominator. Then example, yeah. Okay, so next is classify the following numbers are rational or irrational. So the given number is 2 minus root 5. So 2 is what? Rational number, right? And the root 5 is irrational number. Okay. So when you subtract a rational number with the irrational number, the final number will be irrational number. So the answer is irrational. Okay. Then next is 3 plus root 23 minus root 23. So this plus root 23 minus root 23 cancel. This will be 3. What is 3? 3 is a rational number. So the answer is what? Answer is rational. Very simple. Very simple. Okay. Next question. 2 root 7, 2 root 7 divided by 7 root 7. So root 7 cancel. So will be 2 by 7. What is 2 by 7? This is in the form of P by Q. So this is what? This is a rational number. Then 1 by root 2. 1 by root 2. Okay. What is this? 1 by root 2. This is rational and this is irrational. As I already told you, you divide rational with irrational, the final answer will be irrational. So 1 by root 2 will be what? 1 by root 2 will be irrational. 1 by root 2 will be irrational. Next is 2 pi. So 2 pi means pi is what? Pi is irrational number and 2 is rational number. When you multiply a rational number with irrational, the final answer will be irrational number. So the answer will be irrational. The answer will be irrational. Okay, next is a simplification. Just the given number is 3 plus root 3. 3 plus root 3 into 2 plus root 2. Okay, just to multiply. First multiply with 3 into 2. So that means 3 into 2 plus then 3 into root 2. That means 3 root 2 plus next is 2 root 3 plus next is root 3 into root 2. So root 3 into root 2, right? So what is 3 into 2? 3 into 2 is 6 plus what is 3? 3 into root 2? 3 root 2 plus 2 root 3 plus root 3 into root 2. Root of 3 into 2 is 6. So 6 plus 3 root 2 plus 2 root 3 plus root 6. This is the final answer. Next question. 3 plus root 3 into 3 minus root 3. So this is in the form of identity a plus b into a minus b. What is a plus b into a minus b? A square minus b square, right? A square minus b square. So the answer will be 3 square minus root 3 square. 3 square minus root 3 square. 3 square is 9. So 9 minus root 3 square is root 3 into root 3. That is 3. So the answer is 6. Okay. So the answer is 6. Then next is root 5. Root 5 plus root 2 the whole square. A plus b the whole square form, right? What is a plus b the whole square form? A square plus 2ab plus b square. So that means root 5 the whole square plus 2 into ab, root 5 into root 2 into 2ab, sorry, 2 into root 5 into root 2. So 2ab plus, sorry, 2ab plus 2ab plus b square. B square is root 2 square. So root 5 square is 5 plus 2. Root 5 into root 2 is root 10, right? Root 10 plus root 2 square is 2. So what is 5 plus 2? 5 plus 2 is 7. 7 plus 2 root 10. So the answer is 7 plus 2 root 10. So the answer is 7 plus 2 root 10. See, the answer is 7 plus 2 root 10. Oh, okay. Next question. Root of 5 minus root of 2 into root of 5 plus root of 2. Root of 5 into root of plus root of 2. So again, this is in the form of a minus b into a plus b. That will be a square minus b square. So that means root of 5 square, a square minus b square, root 2 square. So that means root 5 square is 5. So 5 minus root 2 square is 2. So 5 minus 2 is 3. So the answer is 3. So the answer is 3. So rationalization, I already explained what is rationalization. Here it is 1 by root 7. So you just multiply with what? Root 7 by root 7. You will get the answer. Okay. Very simple. Then if you any doubt, you check the previous problem. Okay. Same technique. No difference. So here the question is rationalization 1 by root 7 minus root 6. Okay, multiply with the conjugate. That means root 7. Here this is minus. You multiply with the plus root 6. Divided by root 7 plus root 6. Okay, solve it. You will get the answer. Okay, finally you will get the answer. If you have any doubt, you can refer this. This is the solution. Okay, apply the same step what I discussed earlier. Then next is this one. 1 by root 5 plus root 2. Again, multiply the conjugate. Here the sign is plus. You have to multiply with the minus. So root 5 minus root 2 divided by root 5 minus root 2. When you multiply, simplify, you will get the answer. Understand? So the answer is root 5 minus root 2 divided by 3. Again, same problem, rationalization. 1 by root 7 minus 2. So you have to multiply with the conjugate. Root 7. This is minus, so plus. Take the conjugate, plus 2. That means root 7 plus 2. Okay. Here you can see. And finally, you will get the answer. Root 7 plus 2 divided by 3. Next is we are going to apply the laws of exponents. Okay, we already studied the different laws of exponents. First, we will start with a raised to m into a raised to n is equal to a raised to m plus n. So here the question is 2 raised to 2 by 3 into 2 raised to 1 by 3. So here this is m, this is n, and this is a, right? Now this is in the form of a raised to m into a raised to n. What is the answer? A raised to, that means 2 raised to m plus n. M plus n is 2 by 3 plus 1 by 3. So this will be equal to 2 raised to, take the denominator 3, LCM 3. So this will be 2 plus 1. So this is equal to 2 raised to 2 plus 1 is 3 by 3. That means 2 raised to 3 by 3 is 1. 2 raised to 1. So the answer is 2. Okay. So by applying this a raised to m into a raised to n, your answer will be 2. Next law of exponent is a raised to m, the whole raised to n is equal to a raised to mn. So the question is 3 raised to 1 by 5, the whole raised to 4. Okay. So this 3, this is a, this 1 by 5, this is m, and this is n. So this will be equal to, you can write, so this will be, you can write 3 raised to 1 by 5, a raised to m into n, mn. So that means 3 raised to, n is what, 4. That means 3 raised to 1 by 5 into 4. This will be 3 raised to 4 by 5. So the answer is 3 raised to 4 by 5. So the answer is 3 raised to 4 by 5. Then another law of exponent, a raised to m divided by a raised to n equals a raised to m minus n. So the question is 7 raised to 1 by 5 divided by 7 raised to 1 by 3. So this is a, this is m, and this is n. So this will be a raised to, so that means 7 raised to m minus n, 1 by 5 minus 1 by 3. So equal 7 raised to, here the, check the denominators 5 and 3. So I am taking 5 into 3, 15 as the LCM. So 15 by 5, 3. So 3 into 1, 3 here, minus 15 by 3, 5. 5 into 1, 5 here. So this will be 7 raised to 3 minus 5 is minus 2 by 15. 7 raised to minus 2 by 15. 7 raised to minus 2 by 15. Okay, so next question is 13 raised to 1 by 5 into 17 raised to 1 by 5. Here the power, both the power are same. So you can write 13 into 17, the whole raised to 1 by 5. 13 into 17, the whole raised to 1 by 5. 13 into 17 is 221. So 221, the whole raised to 1 by 5. So different laws of exponents we already discussed. A raised to m into a raised to n equal to a raised to m plus n. A raised to m divided by a raised to n equals a raised to m minus n. A raised to m, the whole raised to n equals a raised to mn. Okay. Then next a into b, the whole raised to m equals a raised to m into b raised to m. Then a by b, the whole raised to m equal a raised to m by b raised to m. Any number raised to 0, any number raised to 0 is equal to 1. So for example, 13 raised to 0 equal to 1. So 100 raised to 0, any number raised to 0 is equal to 1. Any number raised to 0 is equal to 1. Any number raised to 0 is equal to 1. Then a raised to minus m equals 1 by a raised to m. Okay, any number raised to a raised to minus m is equal to 1 by a raised to m. Okay, and one more thing, a raised to m by n equals, you can write n the root of a raised to m. Okay, so simplify the following expressions. 64 raised to 1 by 2. So as I already told you, a raised to m by n is equal to n the root of a raised to m. So this will be equal to n the root of, here the value of n is equal to 2. That means the square root of the value of a, 64 raised to m is 1. So the square root of 64, what is the square root of 64? 8. So the answer is 8. Next question is 32 raised to 1 by 5. Okay, so this you can write n the root of, here 1 by m by n is 5. So n the root of 32 raised to 1. What is the fifth root of 32? That means 2. So when you multiply 2, 5 times 2 into 2, 1, 2, 3, 4, 5. When you multiply 2 into 2, 4, 2 into 2, 4, that means 4 into 4, 16. So 16 into 2. So 16, what is 16 into 2? 16 into 2, 2, 1 balance, 32. So the answer is 32. So the fifth root of 32 is equal to 2. Fifth root of 32 is equal to 2. Then next is 125, the whole raised to 1 by 3. This will be equal to, again you can write n the root of cube root of 125, the whole raised to 1. So what is the cube root of 125? Cube root of 125 is 5. That means when you multiply 5 into 5 into 5, the solution is 125. 5 into 5 is 25. 25 into 5 is 125. Next question is 9 raised to 3 by 2. So what is 9 raised to 3 by 2? So that means n the root of, so n is 2. So n the root of 9 raised to 3. Okay. Okay. So this one I can write 9 raised to 3 by 2 is equal to n the root of what? N the root of 9 raised to 3. So you can write square root of what? Square root of 9 raised to 3. What is 9 raised to 3? 9 raised to 3 is 9 raised to 3 is 729. So okay, square root of 729 is 27. So the answer is 27. So the answer is 27. Next is 32 raised to 2 by 5. So this will be m by n. N is 5. That means fifth root of 32 raised to 2. So what is 32 raised to 2? 64, right? So that means fifth root of 64. Okay, so this one we can, so this is 32, the whole raised to 2 by 5, right? So this one I can write, uh, this one I can write 32 raised to 1 by 5, the whole raised to 2, right? So what is 32 raised to 1 by 5? That means this is the fifth root of 32. So fifth root of 32, the whole raised to 2. What is fifth root of 32? Fifth root of 32 is 2. So 2 square. So the answer is 2 square 4. So the answer is 4. Then next is 16 raised to 3 by 4. So this one I can write 16 raised to 1 by 4, the whole raised to 3. So that means fourth root of 16, the whole raised to 3. Okay. So what is the fourth root of 16? 2, right? So 2 into 2, 4. So 2 into 2, 4 into 2 into 2. That means 4 into 4, 16, right? So 2 raised to 3. What is 2 raised to 3? 2 into 2, 4, 4 into 2, 8. So the answer is 8. So the answer is 8. Next is 125 raised to minus 1 by 3. This one I can write a raised to minus m equal to what we studied. A raised to minus m equal to 1 by a raised to m. So this will be 1 by 125, the whole raised to 1 by 3. So this will be 1 by this one, 125, the whole raised to 1 by 3 means square root of 125. So what is square root of 125? 5. So the answer is 1 by 5. Then next is 2 raised to 2 by 3 into 2 raised to 1 by 5. So this will be a raised to m into a raised to n. So that is 2 raised to 2 by 3 plus 1 by 5. This will be 2 raised to 15. 15 by 3, 5 into 2, 10 plus 15 by 5, 3 into 1, 3. So 10 plus 3 is equal to 2 raised to 13, 13 by 15, 2 raised to 13 by 15. Then next is 1 by 3 raised to 3, the whole raised to 7. 1 by, what is 3 raised to 3? 3 into 3, 9, 9 into 3, 27. 1 by 27, the whole raised to 7. That means 1 by 27, the whole raised to 7. Then 11 raised to 1 by 2. 11 raised to 1 by 2 divided by 11 raised to 1 by 4. That means 11 m minus n. That means 1 by 2 minus 1 by 4. So this will be 4 LCM, 4 by 2, 2, 2 into 1, 2, minus 4 by 4, 1, 1 into 1, 1. So 2 minus 1 is 1. So 11 raised to 1 by 4. So the answer is 11 raised to 1 by 4. So the answer is 11 raised to 1 by 4. Next is 7 raised to 1 by 2 into 8 raised to 1 by 2. So 7 raised to 1 by 2 means root 7 into 8 raised to 1 by 2 means a root 8. So that means root of 7 into 8. What is the root of 7 into 8? 56. So the answer is root of 56. Okay, so we discussed about all the topics from this chapter, number systems. So we will do a quick review. So we start with the natural numbers. The natural numbers, we know that starting from 1. So the smallest natural number is 1. So 1, 2, 3, etc. Then we studied about the whole numbers. So whole numbers starting from 0. So the smallest whole number is 0. Then 0, 1, 2, 3, etc. Integers. Integers means contains positive numbers, negative numbers, and 0. For example, minus 3, minus 2, minus 1, negative numbers, 0, then 1, plus 2, plus 3, etc. So integers includes positive numbers, negative numbers, and 0. Then we studied about rational numbers. Rational numbers means any number we can write in the form of p by q, where p and q are integers, and q not equal to 0. And q not is equal to 0 are called rational numbers. Then we discussed about irrational number. Any numbers we can't express in the form of p by q is called irrational numbers. Their decimal expansions are non-terminating and non-repeating. Examples root 2. Examples of irrational numbers are root 2, root 3, pi, e, etc. Then we studied about real numbers. Real numbers means rational and irrational numbers. Both are called real numbers. Then how you will represent real numbers on a number line. Whether you can represent both rational numbers and irrational numbers on the number line. Okay, we discussed about how you can locate an irrational number root 2, root 3 on a number line by using Pythagoras theorem. Hypotenuse square equal base square plus altitude square. Remember the equation, Pythagoras theorem. Hypotenuse square equal base square plus altitude square. Then we discussed about various operations on real numbers such as addition, that means sum, subtraction, difference, multiplication, product, and division, that means quotient of real numbers of different numbers, right? Then we studied about laws of different, then we applied different laws of exponents to these numbers. A raised to m into a raised to n, a raised to m by n, a raised to m the whole raised to n. And we know that any number raised to 0 is equal to 1. Okay, so the important points and finally, I'm going to end this chapter. So this, yeah, every irrational number is a real number. Okay, So we already discussed real number means both rational and irrational number. No, so every irrational number is a real number. The decimal expansion of rational numbers is either terminating or non-terminating but repeating rational numbers. So the decimal expansion of rational numbers is either terminating or non-terminating but repeating. But in the case of irrational numbers, the decimal expansion is non-terminating and non-repeating, non-recurring irrational numbers. But in the case of rational numbers, either terminating or non-terminating, repeating. Between any two real numbers, there exist infinitely many and rational numbers. For example, if we have two rational numbers, for example, if any two real numbers, I am taking 1, 2. Okay, between 1 and 2, there exist infinite number of rational and irrational numbers exist between two real numbers. Okay, so that's all about this chapter about number system. You can watch this video again and again and solve all the problems one by one what I discussed in this video, and practice again and again so that you will be more confident in this chapter. So next video, I will explain the next chapter. Okay, thank you.